Hello everyone. Now let us take one more session on miscellaneous problems. Now this session perhaps would be the last session for combinatorics. My first illustration is that number of non-negative integer solutions of the equation 3x plus y plus z equal to 24 is, and now four options are given to us. Again, as usual, correct option is to be marked. Now 3x plus y plus z equal to 24, and what we have done before, they are not similar. There we had x1 plus x2 plus x3 etc. Means coefficients of those xi's was always 1. Here x has coefficient 3. So it is not straight application of what we have done. We will have to do little arrangement, some adjustment, and then we will be answering the question. So to get number of non-negative integer solutions, idea or method, procedure, what we had used before, same would be used. But we will have to deal with that 3x plus y plus z. So that 3x perhaps could be a troubling factor. Now, again, do that systematically. What we do is, we take that 3x into account and I give different values to x and actually set the matter. If I take x equal to 0, then y plus z would be simply 24. And now question remains to get number of non-negative integer solutions of y plus z equal to 24. Whatever solutions you get, along with that, if you have to attach only x equal to 0. So number of non-negative integer solutions of this case when x is 0 and the required case would be actually similar. So we actually count number of non-negative integer solutions for y plus z equal to 24. And here 24 coins, there is only one plus sign. So we will have 24 ones, 1 0. So in all 25 quantities, 24 are of one type. I'm just revising that so that your thought process starts. So here in the second column where you are writing number of non-negative integer solutions, my first situation answer is 25C1, which is 25. Now I take x equal to 1. If I take x equal to 1, y plus z will become 21. And now 21 coins, 1 0 means 21 coins means 21 ones, 1 0 because of that plus 1 sign there. Then I will be having in all 22 quantities, so 22C1. So answer is there 22. Go for x equal to 2. Y plus z is 18. So answer there would be 19C1. Go to next in similar manner. Go for x equal to 7. That would reduce only to y plus z equal to 3. And y plus z equal to 3 means then number of non-negative integer solution would be 4C1. And last case would be x equal to 8. The moment you write x equal to 8, y plus z would be 0. And you are looking for non-negative integer solution. So y and z both have only one option. 0, 0. So number of non-negative integer solution there, if you are writing, answer would be 1. So in all, total would be the required number. So you will have to add all of them, and that 1 plus 4 plus 7 plus 10 up to 25 you have. And now if you see those numbers written there, they all are in arithmetic progression. So those who know how to write some of numbers which are in arithmetic progression, they can use formula or you just simply add those numbers. I have used the formula to make it shorten, and then my correct answer in this would be 117, which is option A. So I mark option A. Okay. So let us proceed from here to the next one. Now second illustration is 10 people, including A and B, are to be seated on a rectangular table, 5 seats on each side, and we have to find the number of seating arrangements so that A and B, they do not sit next to each other and they do not sit opposite each other. Okay. And again, 4 options. Now it's better that I make some figure to make things clear. Now if you are looking for cases, then how those cases should be? They should be mutually exclusive and exhaustive. So that exhaustive when I say and exclusive when I say, you count numbers of each case and just add them together and make sure that correct count you have found. So I break the situation into 2 particular cases. I write person A sits in a corner seat. So if he sits in the corner seat, then actually A has 4 options, those 4 corners, right? But also I have made cross there to a seat which is straight opposite to A and next to A, because these 2 seats are not available for B. So which all other options are for B? A chooses his seats in 4 ways, but what about B? B chooses wherever I am ticking, like putting the right mark. And I understand that B has now how many options? B has 7 options because 3 seats are gone out of 10 places. So B chooses his seat in 7 ways, right? A has chosen in 4 ways. Now what about remaining 8 people? Even they are to be seated, correct? So remaining 8 people will take their seats in 8 factorial ways. So 4 into 7 into 8 factorial is the number when A chooses to be at a corner seat. What about second case? Second case also we will have to take separately, where A chooses to be a non-corner seat. So some figure I have shown there. Now I start with this case. A has how many options? If he has to sit on non-corner seats, 4 corners are gone, right? So 6 options are available for A. What about B? B does not sit wherever I have marked cross. So B has now 4 seats have gone for B. So 6 options are available for B also. So B chooses his seats in 6 ways. A chooses in 6 ways. And what about 8 people, remaining ones? They also choose those 8 seats in 8 factorial ways. So number of ways to select chairs or that particular sitting arrangement would be 6 into 6 into 8 factorial in this case. And then total, finally, it would be 4 into 7 into 8 factorial plus 6 into 6 into 8 factorial. So evaluate it and that would be nothing but 64 into 8 factorial. So my correct option is D, right? Let us move to the next. Can you see the variety? Like no two questions look similar. So you have to be alert. This is what I have been emphasizing on. So let us go to the third one. And the third one is A, B, C. These 3 numbers are from the set 1, 2, 3 up to 14. And A, B, C appear in that polynomial where Px is described as ax square plus 2bx plus c. The number of polynomials such that x plus 1 divides the polynomial. And then 4 options as usual. Correct option we will be choosing. Now Px equal to ax square plus 2bx plus c and x plus 1 divides Px. Recall your algebra. We have done when a factor x plus 1 divides. When does it happen? Factor theorem. It tells us that P at minus 1 must be 0. Now if I substitute in place of x as minus 1, I will be getting a minus 2b plus c equal to 0. And that tells me that 2b is a plus c. Correct? So this further tells me something. See that one thing that x plus 1 divides px has actually opened the channel. And this tells me that a and c must be having same parity. Why do I say so? Because a plus c is to be an even number. And an even number is expressed as sum of 2 quantities. Then what those 2 quantities should be? Either both of them are even or both of them are odd. So when I say both of them are even or both of them are odd, it comes under one same statement that I am saying they have same parity. So basically, we are supposed to choose A and C. B will automatically get fixed. So we are not bothered for B. We will be just concentrating on A and C. Now, if A and C are to be obtained, they are to be obtained either from even numbers or they are to be obtained from odd numbers only. So, how many even numbers are available? 7 even numbers are available. So, you actually select 2 of them, 7C2, and then A and C, they can interchange also their numbers, right? So, into 2 we will have to do. So, 7C2 into 2. That is how I understand. But there are people, those who would say, I may write directly 7P2. Choice is entirely yours. I generally select and then arrange. I find that way better. Now, if A and C are to be chosen from the odd ones, similar logic, then that would be 7C2 into 2. So, the required number finally has to be 2 into 7C2 plus 7C2. I have deliberately given those 4 options also in C2 form only so that you can understand from where that 7C2 must have occurred. But in the main examination, perhaps such a number would be evaluated and it would be given to you. Okay. So from here, I go to my next question and I mark correct option as D. And the next one, the last one perhaps of this session is 20 lines are drawn in a plane. No 2 lines are parallel and no 3 lines are concurrent. Now this is a general statement so that you realize that no special cases you are going to consider. Okay. The number of disjoint parts these lines divide the plane into is. Language looks strong. So you must understand wording and you must concentrate on those wording. Wording is the number of disjoint parts those lines divide the plane into. Means what? You draw one line. It divides the plane into 2 parts. You draw 2 lines. then it would divide the plane into perhaps 4 parts and so on, right? So we actually do this in a systematic manner, not actually sit and count like that. Now I will write, let un denote the number of parts that n lines divide the plane into, and then start concentrating on what we mean by u1, u2, etc. One example I have written there, 3 lines divide the plane into 7 disjoint parts. That actually I have shown, those 7 disjoint parts. That does not mean you will actually draw those 20 lines. It is impossible. It's only one example, so that what are we doing, you should get that clarity. So I have drawn that figure. Not all 20 lines, right? Now go for u1. What is u1? u1 means one line divides the plane into how many parts? 2 parts. So answer is 2. Now when I go for u2, I have already mentioned that 2 lines divide the plane into 4 parts. I could have written directly 4 also, but I have deliberately written that as u1 plus 2, so that some pattern you will get. u3, I already mentioned, it divides the plane into 7 parts. I could have written u3 as 7, but what I am writing here deliberately as u2 plus 3. I am seeing their pattern. I am writing u1 plus 2, u2 plus 3, and so on. Now that you know that how finally I will be writing u20, correct? That would be u19 plus 20. Can you see that pattern, what I am saying? Now u2, you have written u1 plus 2. When you write u2 on left hand side, subscript is 2, you are saying plus 2 is there. When you write u3, you are saying plus 3, correct? So if you write u20, I must mention there plus 20. So u20 is u19 plus 20. Now I have found u1, I have found u2, etc. Now one idea comes to my mind is that if I add all of them, what will I get? On one side I will add u1, u2, u3 up to u20, and on right hand side I will get some as u1, u2, u3 up to u19, correct? So when you add all of them, that u1 to u19 part may get cancelled and you will get straight away u20. That is the beauty of this method, that why did I select un and why did I write u2 in terms of u1 and u3 in terms of u2. Here it becomes very, very clear that u20 straight away I can get. And what u20 means? u20 stands for that 20 lines divide the entire plane into how many parts. So straight away you are going to get your answer. I hope you appreciate this point. Now this is nothing but 2 plus 2 plus 3 plus 4. You add that numbers what are written there on the right hand side, and that would be finally, I have actually added and written that final answer as 211. I hope this problem was very, very different from the previous one. Counting only has been done, no particular principle we have used. As long as we are counting, this problem becomes part of combinatorics. But that whole crux was that un, defining un, such ideas if strike you, then nothing like that. Okay, I hope you enjoyed this, the entire chapter. Please keep revising. That revision and practicing more and more problems only will give you more and more clarity in this particular chapter. Okay, so we will meet next time again with some new chapter. Hope you have enjoyed the session. If you have liked the video, please click on this side, and if you want to place an order for the book, click on this side. Thank you.